Hello, grade 12. Welcome to the grade 12 mathematics summer lessons. And today I just want to introduce a different series. And this is basically part 1. And I'm just going to start with grade 12 functions. Okay, don't forget, we are still doing grade 12 online mathematics. Okay, so let's take a look at the content outline. And you can see I've just put a picture of two textbooks. It's Platinum Mathematics Learner's Book and Mind Action Series. So these are the two textbooks that we'll be using in order to conduct these sessions for functions. And here I just put a picture of the just an outline of what we are trying to do and what we have already achieved within our sessions, our previous session. Don't forget, we have a session on arithmetic sequences, on patterns, sequences, and series, and that's where we covered our topic 1, and we did all those 7 sessions, right? Okay, so today I want to introduce to you unit 1, which is functions. It's just gonna be very short, just an introduction to grade 12 function. It's just building up on what you learned in the previous grades, grade 11, grade 10, and grade 9, like that. So it's in grade 12 they just add this small knowledge, and that's where they're just building up on just your previous knowledge. So we are just going to focus on unit 1, which is functions, and it's on page 34 on your Platinum Mathematics textbook. Some of the examples and resources were taken from Mind Action Series Mathematics textbook. Okay, grade 12, let's get to it. Function. So what comes in your mind when you think of function? Okay, I know when many learners think of function, what might come to their mind is, okay, graphs, functional graphs, linear graph, exponential graph, hyperbola, parabola, like that. You think of those graphs, right, when you think of function. But now in grade 12, really, they really want you to understand what is a function rather than that just a mere picture of you getting all those kind of graphs and being asked range, domains, to sketch the graph, asymptote, and all that. So in grade 12, really the focus is you have to understand what is a function, right? Okay, function are graphs, but not all graphs are function. You'll understand it, you see. So as we move within this lesson. So what is a function? A function is a rule or a relationship between the domain, which is values of x, and the range. Remember, for a graph, when you sketch a graph, you plot using your values of x and your values of y. And those values of x in which the graph is going to cover, we call them the domain, right? And those values of y in which your graph is going to cover, we call them the range. So a function is a relation between these two values, the values of x and the values of y, right? But how is this relation? How is this rule? This rule says that for that graph to be a function, for a single value of x, right, where one element or a value of x must only correspond with only one value of y. This is a key statement that you must understand so that you may be able to understand what really is a function, right? We are saying when we sketch a graph, we are using the values of x and the values of y. And all values of x in which your graph is covering, we call them the domain. All values of y in which your graph is going to cover, we call them the what? The range. So now to say this is a function, we must get that there is for any element of x, right? For any element of x, of a single element of x, it must correspond to only one element of y to say this graph is a function, right? So in some cases there might, however, be many elements or values of x, right? We might have many values of x, but for it to be a function, they must be corresponding to only a single value of y, right? So So you get a sense that for something to be a function, okay, it's a rule that says that there must only be one value of y for any value of x. There can be many value of x corresponding to, but there must be corresponding to only one value of y. Only one value of y. So that thing is called a function. So in a case where you get many values of x corresponding to only one value of y, we call this type of function many to one function, because you get like many values of x are corresponding to a single value of y. So we call this many to one function. But we will explore these different types of function as we proceed with our session, right? Okay. So, but however, a relation is not a function if one element or many values in the domain x are corresponding to more than one or many values of y. So if you get that a single value of x or many values of x are corresponding to more than one value of y, then that thing is not a function, because for a graph to be a function, there must be many values of x or a single value of x corresponding to only one value of y, right? Then it is called a function. But in a case where you get that there are many values of y that are corresponding to a single value of x, like that, then we call that not a function, right? So it's not a function because there are many values of y for a single value of x. So that is not a function. Okay, let's take a look at this picture that I put here, and so that you may be able to understand what we're trying to say here. Okay, in this picture, let's take a look at this first one here, right? This is a function. Why is it a function? Okay, what I did here, we take the domains, the values of x in which the graph is covering, and the range, which is our output there, the values of y in which the graph is covering. And if you can take a look, a single value of x is corresponding to a single value of y. A single value of x corresponding to a single value of y. 3 is corresponding to 6 in the range there. So you can see that this is a function. Why? Because there is only one value of y for each value of x, of a single value of x. There is only one value of y. We are not getting that maybe a single value of x is corresponding to more than one values of y, right? So that one is a function, right? So let's take a look at the second picture here. Let me just do it properly. Okay, just use this one. If you can check, two values of x are corresponding to a single value of y, right? Add that two values of x, which is 2 and minus 2, they are corresponding to a single value of y. One value of x corresponding to a single value of y. It's also a function. Why? Because we get that many values of x are corresponding to only one value of y. It's still a function. For a case where it's not a function, it's where you get that one values of x is corresponding to more values of y. Then it's not a function. But this is still a function, and I just highlighted it here. If you can check that we can have in some cases many values of x corresponding to only a single value of y. So it's still a function, and we call it many to one function, but we'll explore that soon. Not a function. Let's take a look at this one. Not a function. It's where we get a single value of x is corresponding to more than one values of y. You can see 1 is corresponding to 1 and minus 1. So it's more than one values of y. Even 2 is corresponding to more than one values of y. Then this is not a function, right? So it's a rule or a relation between the domain and the range, or between the values of x and y. So I hope you now understand what is a function and what is not a function. Okay, let's now explore these different types of function, right? So we have two types of function. We have a one-to-one function, and we also have a many-to-one function. Okay, and I already explained this in the previous slide. It's just that I just want you to deeply conceptualize this information. Okay, so with a one-to-one function, it's where a single value of x is corresponding with a single value of y, right? A single value of x correspond with a single value of y. You can see -2 in the domain corresponding with 1, 4 is corresponding with 6, 5 is corresponding with 7, 3 is corresponding with 9. So you can see single value of x is corresponding with a single value of y. So we call this a one-to-one function. Okay, number 2, many-to-one function. It's where you have that more than one values of x will correspond with a single value of y. Remember, for a function there must always be a single value of y, right? So more than one values of x will be corresponding with a single value of y. For example, look at this. When you put 0, you get 4. When you put 1, you also get 4 as your y, right? You can see that more than one values of x there are corresponding to a single value of y. So we call it a many-to-one function, right? A many-to-one function. So these are just two types of functions that we have. Okay, so not a function, the relation is one-to-many, sort of like one-to-many. For example, you get that this is not a function, right? So it's not really classified under types of function, or that just put it so that you can get this sort of like different and comparison between types of function and those ones that are not a function. Okay, so we obviously know that if something is not a function, there are more values of y for maybe a single value of x, right? For example, a single value of x corresponding with more than one values of y. So this is not a function, right? So but the relation really, if you check, is one to many. One to many, all those one to many will not be a function, because a single value of x is corresponding with more than one value of y. So if it's like that, it's not a function. Okay, let's now take a look at how to determine whether a graph is a function or not using another method, right? This is another method really to determine whether your graph is a function or not, and if it is a function, how to determine the type of function it is. So we now look at something called the vertical line test and the horizontal line test. So the vertical line test, as you can see there in green, it's this line. This is a vertical line, right? This one is a vertical line. So this one, it is used to determine whether a graph is a function or not a function, right? How do they do so? If a vertical line cuts the graph at one point throughout the graph, if you apply a vertical line and it's cutting the graph at only one point, then the graph is a function. That's it. Very simple. So if a vertical line cuts the graph at more than one point, for example, if you apply a vertical line and you see it's passing on the graph at more than one point, then the graph is not a function. So that's another method you can use to determine whether a graph is a function. You can simply apply a vertical line. If it's cut once, it's a function. If it's cut more than once, then it's not a function, right? Then horizontal line test. Now with the horizontal line test, it is now used on those graphs that are functions, right? The graphs that are functions only, right? So if a graph is a function, then we might want to know what type of function it is, right? So we then use a horizontal line test, right? And then in red, I think it's red, if not maroon, it's our horizontal line, right? That is our horizontal line. So if our horizontal line cuts the graph at one point throughout the graph, right? If you apply a horizontal line in a graph and it cut your graph at one point, then your graph will be called a one-to-one function. that's a type of function. It will be called a one-to-one function, because when you apply a graph, a horizontal line, it cut your graph at one point. So it's a one-to-one function. Then, but if it cut your graph at more than 1 point, right? So if you're applying your horizontal line and it's cutting your graph at more than 1 point, maybe 2 or 3 or something like that, so we call that graph a many-to-one function. So this is just another method that you can use, and it's a very quick and simple method. You just need to know, if I apply my horizontal line, cut my graph at 1 point, then it's a one-to-one function. If it's cut our graph, it's more than 1 point, then it's many-to-one function. Okay, let's quickly take a look at this exercise, and I'll just use this as an example in order for you to just understand what we were just covering in this lesson. So the question said, determine whether the following relation is a function or not. If the relation is a function, determine whether it's a one-to-one or many-to-one. Also write down the domain and range for each relation. Okay, they want also you to write the domain and range for all this relation. Okay, so I'll basically show you on this picture here. That's where I'll show you. Then you'll use this as your exercise, right? As your fun activity exercise, and you just drop your answers on the comment section. Then I'll just quickly respond there to see if you're on the right track or not. Okay, A. Let's take a look at A. Here's it, right? It's this relation. So if you check your x is 2, you get what? You get y as 5. X0, you get y as 3. X minus 3, you get your y as 0. You can see that for each value of x, there's only one value of y, right? So this is a function. So it's a function. But if it's a function, determine also which type of function, whether it's a one-to-one function or many-to-one function. We can see that a single value of x is corresponding to a single value of y. There's no a thing that we are getting that more values of x are corresponding to one value here, right? So we can see this is a one-to-one function. It's a one-to-one function, right? So that is a one-to-one function. Okay, so B, let's go to B. Here's it is a graph. So if they just give you a graph, you can just use the vertical line test in order to check whether your graph is a function or not a function, right? Just gonna apply my vertical line. You see, if I apply my vertical line at any point in this graph, it's only gonna cut once. So this means that our graph is a function. So this is a function, right? So it's a function. To determine the type of function, I'm just gonna use a horizontal line. If it's cut at 1 point, we know it's one-to-one function. So we see also this is one-to-one function. So this is one-to-one function. Okay, so with the domain and range, let's not entertain it for now. I just want you to know what it's a function or not a function. Okay, let's go to C. Is this a function or not a function? What do we use? The vertical line test. So we're just gonna apply a vertical line. If you apply it at any point, you will realize it will only cut your graph at 1 point, right? So it means that this parabola of ours is a function. It's a function. But let's determine what type of function it is. We are going to use a horizontal line test. Horizontal line test. If you apply a horizontal line, you realize, oh, sorry about this, it's cutting our graph at more than 1 point. So this will be called what? Many-to-one function. So it's many-to-one function because you can see that for if we take a look at understanding, it's many-to-one function because our horizontal line is cutting our graph at more than 1 point, right? But that's just, I think that's just a way you can just memorize and all that. But really looking at understanding, why is it many-to-one function? It's because for a single y value, you can see here we are going to have a single y value. It's corresponding with more than one x values. You can see this is a negative x, this is a positive x. So for these two x values, more than one x values are corresponding to only a single y value. That's why we say it's a many-to-one function like that. Okay, let's take a look at D. But D is like C, because if you check it, it's still the same graph. I think I just made a mistake by putting that there. But if you apply the vertical line, you can see this is also what? This is also a function. It's also a function. And if we apply our horizontal line, it's cutting our graph at more than one point, then that is a many-to-one function. Okay, let's take a look at E. For E, if we apply our vertical line, it's gonna cut our graph at one point, so it means this is also what? A function. This is also a function. But if we apply our horizontal line, it's gonna cut our graph at more than one point, so that one is a many-to-one function. That one is a many-to-one function. Okay, let's take a look at F, last one. If I apply my vertical line, you can see that my vertical line is cutting my graph at more than one point, so it shows that this is what is not a function, not a function. And if it's not a function, then we cannot determine the type of function it is, because it's already out. It's not a function. We don't really need to use the horizontal line because it does not fall under types of function, because it's not a function, right? So, but with understanding why is this graph not a function, let's go back to the definition. Not a function is where we have more values of y are corresponding to a single value of x. It means that a single value of x or values of x in the domain are corresponding to more values of y. And you can really see here clearly that if here I have my x as 1 and here my y maybe as 2, here my y as -2, right? You can see that a single value of x, which is 1, is corresponding to more than one values of y. That is why we say this is not a function. So this will just basically be your fun activity, and I would like you to drop your answers on the chats and to see if you got this right. Okay, great stuff. I'll end this session here. Thank you very much for joining. Don't forget, in this session we were focusing on function, and it's our part 1. I was just giving you just an introduction to what functions are and different types of function and how you can identify them if you are given a graph. And also this focused on 2 aspects, that is your understanding. You must know the definitions, and also I can say that the other aspect was sort of memorizing, or just to know how to apply vertical line and horizontal line test. So as I said, this was part 1 of our function. Part 2 will be focusing on the inverse of a function. Watch out for it, it's coming very soon. Otherwise, let's just call it for a day for today, and thank you very much for joining. Thank you very much for watching, and enjoy the rest of your day. Okay, goodbye.